Good morning, everyone. Myself Muskan. I am from BSc Chemistry Honors final year. My roll number is 54. Today I am going to make an audio recorded lecture for visually impaired students on topic fermentation of organic chemistry. Fermentation. Fermentation is the chemical transformation of organic substances into simpler compounds by the action of enzymes, complex organic catalysts, which are produced by microorganisms such as molds, yeast, or bacteria. Fermentation technology is the use of microorganisms to produce food, pharmaceuticals, and alcoholic beverages on a large scale industrial basis. The science of fermentation is called gymology, principle of fermentation process. The basic principle involved in the industrial fermentation technology is that organisms are grown under suitable conditions by providing raw materials meeting all the necessary requirements such as carbon, nitrogen, salts, trace elements, and vitamins. The end products formed as a result of their metabolism during their lifespan are released into the media, which are excreted for use by human beings and that have a high commercial value. Types based on respiration. Number 1, aerobic fermentation. Aerobic fermentation or aerobic glycolysis is a metabolic process by which cells metabolize sugars through fermentation in the presence of oxygen and occurs through the repression of normal respiratory metabolism. Aerobic fermentation means that oxygen is present. Wine, beer, and acetic acid vinegar, such as apple cider vinegar, need oxygen in the primary or first stage of fermentation. When creating acetic vinegar, for example, exposing the surface of the vinegar to as much oxygen as possible creates a healthy, flavorful vinegar with the correct pH. Homo fermentation, when only one type of product is formed. Heterofermentation, when more than one product are formed. Lactic acid fermentation. Lactic acid is formed from pyruvate produced in glycolysis. NAD plus is generated from NADH. Enzyme lactate dehydrogenase catalyzes this reaction. Lactobacillus bacteria prepare curd from milk by this type of fermentation. During intense exercise, when oxygen supply is inadequate, muscle derive energy by producing lactic acid, which gets accumulated in the cells, causing fatigue. Number 2, alcohol fermentation. This is used in the industrial production of wine, beer, biofuel, etc. The end product is alcohol and CO2. Pyruvic acid breaks down into acetaldehyde and carbon dioxide is released. In the next step, ethanol is formed from acetaldehyde. NAD positive is also formed from NADH, which is reused in glycolysis. Yeast and some bacteria carry out this type of fermentation. Enzyme pyruvic acid, decarboxylase, and alcohol dehydrogenase catalyze these reactions. C6H12O6 in the presence of pyruvic acid decarboxylase or alcohol dehydrogenase formed 2CH3CHO is further converted to C2H5OH plus CO2, ethanol plus carbon dioxide. Citric acid. Citric acid 2-hydroxypropane 1,2,3 tricarboxylic acid derives its name from the Latin word citrus with a molecular weight of 210.14 gram per mole, which contains three carboxylic functional groups with three different values of pKa 3.1, 4.7, and 6.4. Citric acid, a primary metabolic product, is the most important organic acid produced in large quantity and is extensively used in food and pharmaceuticals industries. Citric acid is a tricarboxylic acid, figure 1, formed in the tricarboxylic acid cycle or Krebs cycle and is found in small quantities in all living organisms. Citric acid was first commercially produced in England in 1826 from lemons contain 7 to 9% of citric acid. Until 1919, it is produced mainly by submerged fermentation using Aspergillus niger or Candida sp from different sources of carbohydrates such as molasses and starch-based media. Structure of citric acid: COOH, CH2, CHO, COOH, CH2, COOH. Citric acid production. About 99% of world citric acid production occurs through microbial processes, which can be carried out using submerged or surface cultures. The 70% of anhydrous or monohydrate form of citric acid is used in food and beverage industry as an acidifier or antioxidant to preserve or enhance the flavors and aromas of fruit juices, ice cream, and marmalades. 20% is used in the pharmaceutical industry as antioxidant to preserve vitamins, effervescent, pH corrector, blood preservative, or in the form of iron citrate as a source of iron for the body as well as in the tables, ointment, and cosmetic preparations. In the chemical industry, which uses the remaining 10%, is employed as a foaming agent for the softening and treatment of textiles. A. Surface fermentation using rice bran or other starch or sugar rich substrate have been used for the surface fermentation by Aspergillus niger or in liquid solution in flat aluminium or stainless steel pans. And neither can be used to produce citric acid despite the high content of trace metals in rice bran are used. The citric acid is extracted from the bran by leaching and is then precipitated from the resulting solution as calcium citrate. B. Submerged fermentation. It is a common practice where citric acid is made. The fermenter is made of acid resistant materials such as stainless steel. The carbohydrate sources are molasses decationized by ion exchange, sucrose or glucose, MgSO4.7H2, and KH2PO4 at about 1% and 0.05 to 2% respectively are added. The pH is never allowed higher than 3.5. Copper is used at up to 500 ppm as an antagonist of the enzyme aconitase, which requires iron. 1 to 5% of methanol, isopropanol, or ethanol, when added to fermentations containing unpurified materials, increases the yield. The yields are reduced in media with purified materials as high aeration is deleterious to citric acid production. Mechanical agitation is not necessary and air may be bubbled through. Anti-foam is added. The fungus occur as a uniform dispersal of pellets in the medium. The fermentation lasts for 5 to 14 days. Thank you.